All right, so for section 5.9, it's our last section in chapter 5. We're going to discuss hyperbolic functions, and this is just a brief and quick overview of hyperbolic functions. The textbook does not go into much depth because it's not the depth that you would get out of a non-Euclidean like geometry course. But there are a few things that we can learn about it. So the first thing we need to do is establish what a hyperbolic function is. And it's actually based on a circle. So let's look at the circle x squared plus y squared is 1. It's just a circle of radius 1 with an origin of 0, right? And so it's, going to look something like this, right? And then that circle would be represented by y is equal to 1 minus x squared. Okay, so it's just a circle. All right. Well, then a hyperbola or hyperbola, whatever how you want to say it, would have an equation something like this: negative x squared plus y squared equals 1. And it would look more along the lines of this kind of thing. Okay. All right. And that line would be represented by y is equal to the square root of 1 plus x squared. And if you plug it into your graphing calculator, you would see that. All right. However, many of the trig functions, or all the trig functions that we use, also have a hyperbolic version. So let's look at that. So this is sine h, or the hyperbolic sine of x, would be equal to e to the x minus e to the negative x over 2. Okay. The hyperbolic cosine is e to the x plus e to the negative x over 2. All right. Now, all the other ones are based on reciprocals or different combinations of these. So the tangent, or the hyperbolic tangent of x, is equal to the hyperbolic sine of x over the hyperbolic sine, or the hyperbolic cosine of x. All right. The hyperbolic cotangent of x is equal to 1 over the hyperbolic tangent of x. Secant is 1 over the hyperbolic cosine of x. And then lastly, we have the hyperbolic cosecant of x is 1 over the hyperbolic sine of x. So you can see that these are still closely related to our traditional trig functions. All right. Now, the derivatives and integral list is under theorem 5.20 in the textbook. Okay, so you can check that out in section 5.9. All right. But that all the derivatives, and they're very similar to what they are with our regular trig functions and their derivatives and their antiderivatives, okay? But I do want to go over just a couple examples here about how we evaluate these things. All right. So let's say that I wanted to know what the hyperbolic sine of 7 is, okay? And the reason that we're doing this is because we don't have a hyperbolic sine button on our calculator, so we have to do some things to even be able to plug this in the calculator. All right, so just like I had established, with a hyperbolic sine of 7, it would be e to the 7th minus e to the negative 7th over 2. Okay. Now that you can plug in the calculator, and it comes out to somewhere about 548.316. Okay, So that's how you would evaluate these. You could do this for any and all of those different combinations, as long as you can establish what the sine and cosine is. Then you can find values. Okay. Now this is a calculus course, obviously, so let's find a derivative also. So let's say that we have something like a function of x is the natural log of, we'll say, the hyperbolic cosine of x. Okay. All right. Well, we know, just as a recap, right, that the natural log of x, the derivative of that is 1 over x, right? So the derivative of this, of the natural log, is 1 over the cosine, or the hyperbolic cosine of x. However, we have to also attach this derivative. Okay, again, you can find this under theorem 5.20. All right. The derivative of cosine, or the hyperbolic cosine, is just sine, the hyperbolic sine of x. Okay, so it's not the negative sign or anything like that. It's just the hyperbolic sine of x. And rewriting that to be this hyperbolic sine of x over the hyperbolic cosine of x, we get that the derivative is the hyperbolic tangent of x. Okay, that's all we're going to do with hyperbolic functions. Just be able to evaluate and be able to take some simple, straightforward derivatives. Nothing else. So if you do have any questions, please feel free to email me. But this does conclude our chapter 5, and so have a great rest of your day.